Okay, perfect. So welcome to today's event, which is around decarbonisation of the construction industry. So a topic we've been wanting to do for some time because the construction industry is a huge contributor to our global total emissions. I think, and I'm sure Bob may correct me in his talk, but I think 11% of total emissions up to thereabouts that the construction industry is responsible for per year. So, you know, an area where we absolutely urgently need innovation in decarbonisation techniques to make that as sustainable as possible. And even small changes can have huge gains in our total global emissions, as you'll see from hearing from our speakers today. So we've got two fantastic people coming to talk to you. We've got Gideon, who's the CTO of Converge. Converge has a platform which uses artificial intelligence and sensor data technology to make construction sites more sustainable. Bob, he'll shortly be joining CarbonRe as head of engineering, and CarbonRe have an AI platform which is looking at how we can make the cement and concrete production process more sustainable, more efficient. So with no further ado, I will pass you over to Gideon, who will share his journey with you.
Cool. Thanks, Cherry. Hi, everyone. So I was going to do some slides with sort of brief intro to Converge, but I'll talk through sort of a little bit about what we are and why we're here, and then sort of more on exactly how I ended up here, because it was a slightly non-obvious journey, at least from university. So what do we do? So as Cherry said, we're a sort of an AI platform, and we combine what we call physical data, so anything about what actually happens in the real world, with sort of semantic data, so things about what those things should be, and use those data to improve two things really. So the materials and the logistics of construction in order to improve sort of efficiency, safety, and sustainability. And that's really our core mission, which is on a planet with finite resources, to build the future more efficiently, safely, and sustainably by digitizing the physical reality of construction. And why do we focus there? Well, as was mentioned, construction has two really big problems, I suppose. One is a massive productivity deficit. It's kind of obvious. You go onto a construction site and you start to see that that there are a lot of large cranes and large digging things and quite cool tools, and lots of people dedicated to building the structure, for whatever reason. And construction is probably one of the, I would say, the most important industry that we have. I mean, everything humans do really happens in buildings. Our societies run in the built environment. And yet, when you see the way the buildings are built, you realize that these people are trying to build these incredible structures, but they're really up against it. Like, the digital tools are appalling. And I did meet someone who built a £500 million building in Excel mostly, which was quite impressive, but probably not to be recommended. So our view is that you can't, so that's the productivity problem, and then they have the sustainability problem. So the built environment contributes about 38% of global carbon emissions, construction about 11%, just concrete about 8%. So this is a sector where even if you have a relatively small impact in terms of sector-wide impact, your leverage for the rest, like your impact on the rest of the planet, is actually very high, which is quite satisfying. Which is, one of the reasons we went into, which I'll come back to. And the way we solve this is, our view is that you are measuring something, you can't improve it. And there are many ways of trying to tackle this problem. You could look at financial data for construction companies or whatever, but we thought you really have to look at what's physically happening on construction sites or in the materials plants or in the logistics chain in order to really sort of, make serious improvements. But, as for, and to do that, we basically deploy sensors on construction sites, pump the data into an AI platform, and then try to optimize materials and logistics. But as for sort of my way into this, so I founded the company with a friend of mine from university, what feels like a very long time ago now. And our journey into this is not very obvious. So my background is what at Cambridge we called natural sciences, but my specialism was in theoretical astrophysics, which is not a particularly useful degree if you're going to try to affect the way buildings are built. But what we really wanted to do is, we were looking at different things to do, and we thought, okay, do we want to go an academic route? No, not really. Didn't really fancy being an academic. And we wanted to take sort of a physicsy way of doing things, which is, you instrument some sort of system, you build a model, a mathematical model of how that system behaves, and then you try to work out if your model is correct. Or in our case, you try to change the process underlying it to, produce better outcomes. And we looked for lots of industries to affect. Construction was not obvious. It was very obvious when I went onto a construction site that my hands are very soft. I clearly never done a day of manual work in my life that was not on a keyboard or using a pen. And but it was quite exciting. So we ended up on these construction sites, like in the middle of like Crossrail tunnels as they were being built, which is quite cool if you've never actually been onto a construction site, which we hadn't. And we just started to realize that, all the other industries we were looking at had people working on the digitization. We were still very focused in digitization, really. We didn't quite understand the carbon impacts. We cared a lot about climate change and sustainability. And we were looking at this from a, if you don't digitize these systems, you don't know how much wastage there is in the system. So we were looking from like a wastage or material wastage perspective. Before we really clocked like how bad, because it's not very obvious, like how bad cement is, for example, for the environment, or steel production. And we were on these sites and we noticed that people were checking things using pen and paper on a clipboard. Sometimes they wouldn't go outside if it was raining, so they would just write down the number they thought was sort of appropriate. There was a lot of just a lot of stuff having to be done manually. The way you found out if your building was on track was you would send a plan around with a camera and a clipboard, and they would go and ask people or take photos of things, and then you'd find out, was my building on track? And this meant that the overall operation could be very inefficient. You'd have stuff delivered to a construction site, which would then have to be sent back or piled up in a yard, or was not quite the right thing because it was too windy. And so there were all these inefficiencies which came really from just not understanding what was happening. So we spent some time on these sites and we realized, well, actually, the more we thought about, our first reaction, I'll be honest, was like, construction, this feels a bit difficult, like a bit dirty, it wasn't really our thing. Soft hands. And what we realized was, no, actually, no one was looking at this. I mean, this was in 2015. And when we were raising money the first time, we had investors just laugh at us. They were just like, no, forget it. Like, no one will touch construction. It's a stupid industry to be in. You'll be out of it in 6 months. The investors who did invest in us were either big family offices who had industrial operations, so they understood the importance of affecting industrial systems, or investors who liked us personally and basically were like, oh, we'll invest in you, but like this construction thing, yeah, whatever, you'll be out of it in 6 months. And here we are in 2022. And I think this has now really changed. So the construction tech space is much more vibrant than it used to be. It's the funding story is better in the US, as always, than in Europe. But, Europe's sort of slowly getting there. There are construction tech groups now. It doesn't feel like there are just sort of 5 of us and we're all kind of teetering on the edge of a collapse. So it's a much more exciting space. I think people are really waking up to the fact that construction is this industry which is so fundamental to what humans do, and yet no one's really invested in improving the technical aspects of it. And so as we were, how do we get into this sort of more green part? Because the sustainability aspects are such an important part of our mission, and it was actually from very early on. So we had this like idea that we were going to build this a sort of physical reasoning system to reason about how construction worked. And we would go to construction companies and their eyes would glaze over. And so what we realized is we really had to choose something that was sort of a day zero value proposition. And it was the same from a sustainability perspective. We would go, once we started to realize like how bad this was for the environment and the level of material wastage and the inefficient use of materials, because, if we take concrete, the overspecification of cement, even is about like 1% of all cement. If you can eliminate that, it's something like 40 million flights to New York a year, which is an enormous number. And, we talk a lot about aviation and flying less, but, if you can do things like eliminate overspecification of cement, you've made a huge impact that no human stopping how much they fly is ever going to change. But we used to say this to the construction industry once we started realizing, and again, eyes would glaze over, no one really cared. And that really started to change probably for us, notably from about 2019, when people in the industry, I think were feeling the pressure from real estate investors who are probably getting the pressure from their investors, starting to say, no, actually, you do need, like, this is a greener solution, or there's like this clean tech thing you could be using. And so you're starting to see that pressure. And also the digitization perspective, where people were starting to think more about data. Whereas before, big data in construction was like, you've got a spreadsheet with 10,000 rows. Now they're really thinking about like, oh, we've got these buildings, and in some ways they're emitting a lot of information. We should think about how we store those data and actually utilize them to optimize how we build buildings. And so from about 2019, we really started to see that change. And that's when we started to win deals on the basis of carbon reduction, not just efficiency savings, which was very satisfying, because we sort of felt like we were finally there. And now where we are today, you can go into, and I had this on Tuesday, we were in a meeting with a very large customer of ours, who's probably one of the biggest constructors in Europe. And so much of it was about decarbonisation. And we could stand there at the front of the room and say, oh, we care about decarbonisation. And there was no like question that anyone else in the room cared about decarbonisation. It was like clearly front and center. So that's been very satisfying. But we did sort of end up in this role of sort of, at least in this industry, almost serendipitously. We had an investor who, we were looking at two things. We were looking at this deal that we had with this construction company who wanted to buy the tech we were building, or this really cool thing that we wanted to build around how do you standardize the way sensor networks communicate to each other. And we had an investor who basically said to us, one is a PhD project and one is a company. You have to choose. And we chose the company. And that was really good, because otherwise we would have faffed around building some sort of academic project, which would have been very intellectually satisfying and not very useful. But yeah, I mean, the fact that we ended up in the construction industry was sort of accidental. And I think today it would have been more obvious, whereas then it was very much like we had to fight an uphill battle and tell people, no, actually construction it's not going anywhere, right? It's not going to end. We're not going to stop building buildings. So at some point, someone is going to capture this opportunity, and we wanted to be the people who did that. And likewise, I think now it's also a lot easier and much less of an uphill battle to do the sustainability angle in construction. And the nice thing about it is that the industry is early enough in its like decarbonisation journey that you can actually make real differences, right? A lot of industries, they do like offsetting or other kind of crap, which doesn't make any difference. But construction hasn't yet been snared by like snake oil salespeople. And so there's like going to be a little bit around the edges, but you can really change how people think about this if you get in at this stage, because people are still setting up sort of policies about how to, reduce the amount of cement you use. And we have a big partner company called Holcim, which is probably one of the biggest cement manufacturers in the world. And, they really care about this as well. And they're looking at, how can they, because obviously cement is the worst part of this, right? It's, the biggest part of concrete, and it's the most carbon emitting part. And, everyone is very engaged on like, how do we actually change this story? Because they're all looking to the future and thinking, we're not going to survive if we don't adapt. And so they're starting to call, I think it was Heidelberg Cement is now Heidelberg Materials. All these companies are starting to really adapt on how they talk about this. So it's an exciting time to be in it. And there are a lot more construction tech companies than there were. And there are a lot more people talking about, how do we actually decarbonize this industry, given that your leverage is huge. If you can just affect 1%, right? Like it's an enormous amount of change. And so, yeah, where we are today is we're 42 people. We just raised Series A. It's definitely been a slower journey because construction tech was like distinctly unsexy for a very long time. If you started a Web3 startup or you did something else in blockchain, everyone will give you money. It's great. You won't do anything very useful, but people will give you money. And whereas, industrial tech is slower and harder, certainly. And I think that's changing. But as I said, I think if you go to the US, it's a lot easier, but, Europe is changing slowly in its own way, and we'll hopefully get there eventually. I think I've even gone over my time slot. Sorry.
No, that's fine. That was fantastic. Thank you so much. Really interesting to hear the perspective from somebody that got into that sector so early and has really kind of pioneered and pushed the change in it. So yeah, that's really interesting. And if you've got things that you'd like to ask Gideon, then hold your questions and you can ask those of him in the Q&A section that we'll move to shortly. But I'm sure that both Gideon and Bob will also be happy to share their details in the chat, so that you can perhaps reach out to them afterwards. So I think a lot of what Gideon said there has teed up really nicely for Bob to come in and talk to you about what Carbon Re are doing to improve the problem around decarbonising cement and concrete production, and what Bob's journey into that has been. So Bob, take the floor.
Thank you, Cherry. It's almost as though we planned it. Thank you very much for that, Gideon. I do have slides. I actually wish now I hadn't, because I was actually enjoying Gideon's extemporizing. Can people see my slides? Can you give me a thumbs up if you can see that? Thumbs down.
No, I can see a white rectangle.
Interesting. This tells me I am screen sharing. So let me try that again. We'll stop the share. We will click the button. We will say Firefox and see what it does. I suspect it's because Firefox is full screen. Nada.
And it
Still a
worked
white rectangle.
Well, right? That's okay. We can do this without slides. That's fine. Okay, so hi everybody. My name's Bob. I'm a software engineer. I've got two kids. They're so they're 11 and 17. And I was born in December 1982, back when atmospheric CO2 was at about 340 parts per million. And that's relevant because in November 1982, ExxonMobil wrote a report for their internal executives, which summarized their research into the so-called greenhouse effect. And so their report explained how human beings were releasing greenhouse emissions into the atmosphere that were likely already changing the climate, though they couldn't prove it at that point. And the document predicted that by the year 2020, we'd have reached about 420 parts per million and observed global mean temperature rises of about 1.2 degrees C. The document explains that in order to avert climate change, we would need to make deep cuts in carbon emissions. And so obviously ExxonMobil did nothing about it because that would be bad for business. So it's no exaggeration when I say that we have known about the climate crisis for my entire life. That climate change has been a continual background noise, sort of eerily persistent fire alarm for as long as I can remember. When I grew up, I was an 80s kid, so I grew up watching like Captain Planet and David Attenborough on the BBC. I remember like a really weird advert on Nickelodeon where they sang a song about solar power for some reason. And so, although I remember being terrified about climate change as a kid, like I was vividly aware of the problem, the overwhelming message I was receiving was, we know this is a problem and the grown-ups are going to sort it out. Well, I'm not sure whether you noticed, but the grown-ups did not in fact sort it out. So in a few weeks' time, I'm going to be 40. Atmospheric CO2 is at 420 parts per million, and global mean temperatures have risen by 1.2 degrees C over pre-industrial times, exactly as ExxonMobil predicted. We are now the grown-ups, and we are going to have to sort this out. So about 18 months ago, I decided I was going to work in climate technology. And I didn't know where to go, I didn't know who to speak to, I didn't know what that would look like, but I knew I had to do something, literally anything I could, to avert what was coming, because otherwise I don't know how I will look my kids in the face in 20 years' time. So on Monday, I start my new job. I'm going to be the head of engineering at Carbon Re. And so I want to talk a little bit about what they do and why I think it's so cool. So let me tell you about cement. So cement accounts for about 8% of all human emissions. So that is a huge chunk, right? That is 4 times as much as aviation. We can't stop making cement because, as Gideon points out, cement is the binding ingredient in concrete. We use more concrete than any other substance on Earth except for water. We use about 0.5 ton for every man, woman, and child on the planet per year. That's 4.5 gigatons in 2021 alone. It's a foundational technology for our civilization. And we're going to need more, right? Because concrete builds schools and hospitals and offshore wind farms and flood defenses, all of the infrastructure that we're going to need in order to mitigate climate change and global inequality is going to be built from concrete. So cement is here to stay, at least for the time being. Now, the good news is that cement manufacturers know they have a problem, much like the rest of the construction industry. And so they've all made pledges that they're going to cut to net zero by 2050. Great. The bad news is they are primarily talking to snake oil salesmen. And so they're all waiting for technologies like carbon capture and storage aren't going to be ready anytime this decade. And that matters because carbon has a time value. Okay, the amount of warming we experience is governed by the cumulative emissions that we produce. What that means is that earlier cuts matter more. In fact, it would be better for us to make deep cuts today and not get to net zero by 2050, rather than waiting till 2040 and then finishing up on time. Okay, so net zero is about the journey, not the destination. We need those cuts today. So what can we do about this, right? Manufacturers want to change, but they don't know how to change, and we need to be making cuts today. So what Carbon do, we work with cement manufacturers to improve the fuel efficiency of cement kilns. So a cement kiln is like a massive metal drum, about 70 meters long. It goes round and round and round, and we put rocks in it, and we make the rocks hot. That's how it works. Okay, we heat the rocks up to about 1500 degrees C. And that's how we produce cement. This is an intensely dirty process, okay? So mostly we heat up the rocks by burning coal, but we're always experimenting, and so manufacturers sometimes burn biomass or industrial waste or car tires, right? That's the environmentally friendly option. It is a literal tire fire. And so if you look at the way cement manufacture works, if you want to make cement in your kitchen, you're going to get about 1.5 tons of limestone, so that is calcium carbonate, and you're going to get 0.5 ton of coal, and you're going to burn the coal to heat up the limestone. And when you've done that for long enough, you're going to have about 1 ton of grey stuff, this clinker, that we grind up and we turn into cement. And in the process, you will generate about 900 kilos of CO2, just under 1 ton. So that's pretty bad, right? Now, about half of that comes from the limestone itself, okay? Calcium carbonate, when we make it hot, it reacts with the oxygen in the air and it off-gasses CO2. I can't do anything about the chemistry. That's not my department. There are other people working on that. But the other half, so half of 8%, 4% of all human emissions comes just from burning dirty fuel in cement kilns. So what Carbon do is, if you look at a control room in a cement factory, you sit in front of a bunch of screens, and your job as a human being is to control the kiln, okay, this big rotating metal drum. And your job is to turn up the fan speed or make it spin faster or put more fuel in or whatever it might be, in order to keep the kiln in the sweet spot where the rocks get hot enough and they're in there for the right amount of time to produce high quality clinker. The problem is that humans are inconsistent, right? They've got a lot of screens to look at, they get tired, their kids get sick, they worry about climate change. And so what we see is a lot of process variability. And on a good day, we found the cement kiln can be about 20% more efficient than on an average day. Not a bad day, just an average day. So what Carbon do is we use AI to make recommendations to humans to help them have a good day every day. That's the goal. So there are about 3,000 cement factories worldwide, that's all, producing 8% of emissions. And if we can help those humans operate like they do on a good day, every single day, they will cut their fuel bill by 20%, and we will all save 20% of their fuel emissions, which is just shy of 1% of all human emissions. This is what makes me optimistic about the role of AI in decarbonising the economy, right? Because if one startup in SE1 could find 1% of emissions reductions by tweaking processes in one industry, where else can we find these low-hanging fruit? Where else can we tweak our processes today in order to start to drive those deep emissions cuts that we need this decade? Thank you very much.
Thank you so much. And it astounds me that such a kind of those marginal gains can have such huge impact. It's like you said, really leaves you feeling very optimistic about what possibly can be done. Fantastic. Thank you so much, Bob.